if first number is less than or equal to 5 and greater than 0, you will test if number is odd or even. So if it is greater than 5, we tested if A is odd or even, we printed condition pass. Here it is going to be condition fail. So I can put another if inside of else. Yes? If that condition fails, it would simply mean that A is less than or equal to 5. Inside here, I can test for another condition. What would that condition be? So if the code moves on to the else block, it would simply tell us A is less than or equal to 5. But to complete the activity, I need a condition. What is that condition? Huh? We want it to be greater than 0. So if A is greater than 0, I am going to see if A is odd or even. So if A mod 2 equals 0, this time the condition, the main condition, failed. Main condition is the condition A greater than 5. So main condition fail. The number is even. Still main condition fail. The number is even. Sorry, odd. Now here is a question. The return 0 part, where should it go? Should it go inside that else to do nothing and escape, or should it be elsewhere? It's supposed to be a bad joke. Only one person got it. Nothing part and exiting part, well, sure, I have a return 0 for the main function. If A is bigger than 5, it is going to execute that block right there. Now the activity, simple one that we wanted to do, is less than or equal to 5. So it is going to move into the block in else. Lines 30 through 37 will test if the number is bigger than 0. Well, if A is not bigger than 0, in other words, if it is equal or negative, it has to do nothing. Yes? If you enter a number greater than 5, it is going to test odd or even, but our main condition is the condition A greater than 5. I'm sorry, so right there, we type main condition pass. Otherwise, we do main condition fail, but we still test for odd even. And if we want to do nothing, we can simply put else and return 0. Yes?
Because the main condition failed, why do you need the 80 squared and 0 there? The one line 30?
That one?
30.
Line 30?
Yeah. Like if it fails anyways, why do you need to check again?
What?
Or there, like, what I'm saying is the condition is that it's gotta be greater than or equal to 5. No, less than or equal to 5 and greater than 0, right? That's the condition.
Mm-hmm.
Then, if it fails the less than, lesser, less than or equal to 5 and goes to that, I don't know how to explain it.
I have a greater than 0. In that case, the main condition, which is a greater than 5, failed. And we're still testing to see if the number is odd or even. The do nothing part will happen if you have a negative number or a number that is equal to 0. Yes? Good? Okay. So step 2 is to add the next number or do something with the second number, B. If we enter the doing or not doing anything part, then I'm going to test that second number is greater than 0 or whether it's greater than 100. If it is greater than 100, I am going to print yay. If it is less than or equal to 100, I am going to print sad. So the only way we're going to get into the not doing anything part is if we enter the else block in or between lines 43 to 45. So I can put a print statement or cout statement just to see or just to keep track of where I'm at in terms of execution. So I'll do not doing anything block. In other words, the main condition failed, and inside there I'm going to test if B is greater than 100. Now, I've used the curly braces quite liberally, yes? But do you think that we need all these curly braces? Think back before our hurricane. Jordan says no. Why not?
They're just one-liners.
They're all one-liners. You don't need to have those curly braces at all. So what do I mean by that? Well, I have a one. If B is greater than 100, I simply do cout otherwise I do sad. Now that's the modification that we did. So when not doing anything happens, then we would go ahead and do yay or sad. And not doing anything will only happen if the main condition fails. Yes? So we want it to fail, and if it fails, and if it becomes negative, Then we enter the not doing anything block, at which point we test for B. So you can see that this particular code is pretty messy for such a simple task. Do you agree? And you may say, well, then why did we do all this? Well, you learn by doing. Nested if statements are great. You can use them, but if you keep on adding more conditions on top of nested if, things could get out of hand. You would just confuse yourself, even though you can make the argument that I have one-liners, I could take these curly braces off, the code would become a bit simpler, I wouldn't have as many lines. Sure, that is a valid point, but still, is it good logic? No. So why did we do this? I did this to demonstrate that this is not the efficient approach. So what is an efficient approach, or an alternative to nested if statements? It's to use logical operators. We have relational operators. We've seen relational operators in the past. Do we remember what they are? Greater than, less than, greater than or equal to, less than or equal to. We did not equal to. And when I did that relational operator, I said one of these is also a logical operator. And that would be the not part. So this entire activity that we did here can be simplified and written in a snippet of code if you use logical operators. Good? So next time we will do logical operators.